Okay, traditional geometry. We're about ready to start the law of sines. I just want to go over a couple things here on this packet. Going through the steps, I'll derive where it comes from in class, but I want to make sure you have a video with the steps. Law of sines is relationship between the sides and angles of a non-right oblique triangle. To be honest, you can use law of sines on any triangle. Simply, it states that the ratio, which is a fancy word for fraction, of the length of a side of a triangle to the sine of the angle opposite that side is the same for all sides and angles in a given triangle. You'll notice that capital letters stand for the angles, lowercase stand for the sides, and that matching pairs are capital letter A. Its matching side is the one across from it, would be lowercase a. Same thing, here's the C pair and the B pair. So you would only ever use two of these because we don't solve equations with two equal signs. You may also see it written where everything is flipped, where they say the sine of an angle over its matching side equals the sine of another angle in the triangle over its matching side. Again, you'd only ever use two of those. Those are that is the law of sines, written two different ways. I'm going to go over two examples from the back that Mrs. Evans has. We're going to start with number one. It says find BC. This is side BC, and it doesn't have the segment, so it means the length. I want to find that side. We actually call that side little a because it matches with this angle. The pair that I have right now is the C pair. I put the side on top and the sine of its angle on the bottom equals, the A is what I want to solve for. A, the side, the way we're using it is on top, and the sine of capital A is on the bottom. And when it's a fraction equals a fraction, how I like to do it is I say cross multiply. Please make sure your calculator is in degree mode. I'm going to put in 20 times the sine of 56. When I do that, I get, maybe I'll see it there, 16.58075 equals sine 77 times A. That's the other diagonal. Now to solve for A, I'm going to divide both sides by sine 77. Now to be quite honest, I don't mind how many you write down here, as long as you leave it all on your calculator. When you go divide by sine 77, I get little a is 17.02. I'm going to round to the nearest hundredth on that one. Okay, next one is number 11. This time I'm finding the measure of angle C. That is an angle. So this is what I want to find. So I'm going to set it up. Law of sine always has sine on the bottom. And the pair that I have is the A pair. So it's 14 is the side, sine of 91, they go together. 7 matches with the sine of C. Cross multiply again. Be careful if you have a TI calculator that 91 needs to be in parentheses. I'm going to type in sin 91 times 7 and write that down, which is 6.998933866. I'm just writing it all down. You don't need to. The other diagonal is 14 times the sine of C. Solving for C, so I'm going to divide by 14 on both sides. Notice I wrote it all down. I didn't necessarily need to because I still have it all on my screen. So I'll go divide by 14. 0.4999238476 equals the sine of C. So I need to know what the angle is. Hopefully you remember from right triangle trig that when you need to know the angle, we do inverse. And I'm going to just write it down here. But what's nice on your calculator is that I can hit second inverse, go up and grab it. That way I'm not rounding to the end. And I get 29.99 degrees, or if you're rounding even to the nearest tenth, it would be 30 degrees. And that is the law of sines.